Okay, we are doing the light show problem, and you can see that as cars go in, we need to know how much to charge for those cars. 5 for a car, 8 for a truck, 25 for a bus, and at the end, they want to see some information. So let's see. Once the festival is over, which is the end of the day, they want to know this information. All right, so we need to move over into our problem statement. Now this is the same thing right here. I just copy and pasted it in. You don't need to put this into your problem statement. I just do it, make it a little bit easier. And also did a couple of things. These are the rates, so 5, 8, and 25. And then the scope, one vehicle at a time, only 3 types of vehicles, and the rates do not change and remain constant. So now we have our output. So we just need to paste that in there. So let's see. There's another one. User clicks OK. Ask for another vehicle. If there is one, the process starts over. See, and then the price of admission is going to pop up, so that we need to have that price of admission. Okay. So let's do we'll do a vehicle rate. That was the thing that we read up there that said that we have to tell the person how much they owe for that. So that's going to be the rate for the vehicle. And then the amount of missing some of that. So you need to know how many of each vehicle. So we have cars, trucks, and buses, and we need to know how much. They're going to come in one at a time, which means we have to use a counter. So we're going to have car count, and we're going to have truck count, and we're going to have bus count. And that's going to tell us how many vehicles were admitted. And then we have the money collected for each, the total money of each vehicle type. So we're going to do the same thing again, except it's going to be car cash, truck cash, bus cash, and then total cash. All right, so anytime you see for each type or each vehicle or each something or other, just know there's more than one. So we have to have separate places in memory for each of those types. All right, so now we have all this. Now we need to go and figure out, well, where we're going to get all these. And all of these have to be Control C, Control V. Each of these has to be either filled in with logic or filled in with math. Okay, so we start with the bottom, car cash. So if I know how much total cash. If I know how much car cash, how much truck cash, and bus cash I have, then I just add them all together. So it'll be car cash plus bus cash plus, let's do bus cash again. Let's just keep everything. And this should be truck cash. We'll keep these in order. Just makes it a little bit easier for people to follow what we're trying to do. So we have car cash, truck cash, bus cash. We add them together. So how do we know how much bus cash that we have? Well, it's going to be the bus count times the bus rate. All right, so we do 100 buses and the bus rate is that, then it's going to be $2,500, right? And then truck cash is simply going to be truck count times truck rate. See how easy this is if you're doing it a methodical way. So this is going to be car count times car rate. Students have the biggest problem in the 167 class is trying to figure out the math. But if you figure out the math this way, starting with the bottom and working your way up, you won't have any problems with that class. All right, so how are we going to do this? Well, counters are easy because it's bus count, Control C, equals bus count plus 1. So how easy is that? So if I copy this, Control C, Control V, Control V, and then I'll just have to copy these. Control C, Control V, Control C, Control V. All right, well, that was pretty easy. Now, of course, we can't do all this at the same time. We only want to do the car stuff when it's a car. So we're going to say that if type vehicle equals car, well, then we're going to do the car count. If it's not a car, then we will do truck. Uh-oh, I'm missing the if. And then this is going to be truck. Then we're going to do the truck count. And then we'll do else. So we can do this better. Copy, paste, more space. If it's a bus, then we'll do the bus count. Now, let's move this over. And move this over. Now, we can keep it just like this. And actually, this might be a good way of doing it. Now, when I flowchart it, I'm actually going to move each of the car, truck, and buses into those decisions to make my life a little easier and to make sure that all the math is going to work. But for now, this really works. If it's a car, wait a minute. Aren't I missing something? Where is vehicle rate? Here we go. So I have this output right here, this vehicle rate. I didn't put that. Oh, here it is right here. All right, so the vehicle rate can't go there. It's only after this. So what I'm going to do is say that if the car count is 1, then the vehicle rate equals the car rate. And then we'll do the same thing for each one. Vehicle rate equals the truck rate. And then for the buses, same thing. The vehicle rate equals the bus rate. Now, sometimes what students want to do is they want to put the output of vehicle rate in each one of these, and that would be foolish. So after that decision is over, then we're going to go ahead and output that vehicle rate. Now, the problem is this is a problem statement, so we're not going to do things exactly in the order in which they happen. All we're going to do is be able to talk to our user to figure out how everything is going to work. So the last thing I need is vehicle type. It's got to be input, and car, truck, or bus is the options. And you can see that we use those right here. Our problem statement is now done. So the problem statement is going to be different, or the flowchart is going to be different than the problem statement, and then the code is going to be different than the flowchart. When we get to this point in the class, each of these is used for a specific purpose, and this is to outline how all this is going to work, to show our user what the math is going to be. They can check all this math, to ask them questions about scope. So once they have taken a look at this and said, yes, if you take that in, does that, and we output the rate, great, this all works. And then when we flowchart it, we'll flowchart it differently to put it into the correct order in which things need to be done. And then when we code it, we'll code from our flowchart. But again, the code will end up being different than the flowchart because, for one, we're going to use select case, and for other things are going to be just done differently, especially where we do the math. All right, and that's it for this lesson.